Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2779, maximum beauty of an array after applying operation. This question has been asked in Google several times recently. And here's the problem statement. We are given a zero index array nums, along with that a non-negative integer k. And we need to apply some operation and return some value. Let's explore using an example. This is the array given to us, and along with that a non-negative integer value is also given, k. What is the operation? This is only the given part. And now what is the operation? Operation is that if you are picking any index from the array, you can replace the value of that index to the value from this range. Let's say nums I is the value at ith index. So that value can be replaced with any value from this range. And what is this range? Nums I minus k and nums I plus k. So 4 can be replaced with the range from 4 minus 2, 4 plus 2, 2 to 6. And once you are done with the operations, and these operations can only be applied one per index. For per index, I can apply only one time. So one time on 4, one time on 6, one time on 1, and one time on 2. Like this. So once you have applied the operations, you need to return the beauty of the array. And what is the beauty? Beauty is the longest subsequence of equal element. Let's say initially 4, 6 are there. And 4 can be converted to the range 2, 6. And 6 can be converted to the range 6 minus 2 to 6 plus 2, which is 4 to 8. And this range is from 2 to 6, and this is 4 to 8. And if I choose any value from this range, let's say I pick 5. 5 from this range, 5 from this range. I can replace 4 with 5, 6 with 5. So these will be the subsequence of 2 length. So you have to choose the longest subsequence of equal elements. Subsequence, I hope you understand. Let's say you are given an array 4, 6, 1, 2. If you are removing couple of elements from it, let's say I remove 6 out of it. So this is 4, 1, 2 is a subsequence. I remove 1 as well. 4, 2 is a subsequence. I remove 4, 2 is a subsequence. And all the 4 elements are also a subsequence. Okay. So this was the problem statement. Given an integer array and a value k, apply the operation per index and then return the beauty of the array, longest subsequence with equal element. Let's try to build our approach. We are given that pick any ith element from the array and replace the value of ith element to the value nums I minus k to nums I plus k, this range. Pick any value from this range and you can replace that value to this range. So what will be the value? What will be the range for all of these elements? Here 4 can be converted to range 4 minus 2 to 4 plus 2. That is 2 to 6. Both inclusive. And 6 can be converted. 6 can be replaced with any element from the range. What is that range? 4 to 8. For 1, the range is minus 1 to 3. And for 2, the range is 0 to 4. The range is showing here is that you can replace this value with any value from this range. Replace this value with any value from this range. Replace with this value with any value, and so on. And what we have to return in the end? The longest subsequence. The length of longest subsequence with equal elements. So what can be the possible answer? Let's say 4 is the part of our answer, and I try to make 4. If I pick 4 from this range, 4 from this range, and from this range I cannot pick 4, and I pick 4 from this range. So the array will become 4, 4, 1, 4. Here in this longest subsequence with equal elements are 4, 4, 4, which is 3. Now let's say if you try to convert, let's say if I try to convert it to 3, I pick 3 from this. From this I can also pick 3. From this I cannot pick 3 because 3 is not in the range. From this I can pick 3. And I can convert this whole array to this 3, 6, 3, 3. In this case also, the longest subsequence of value equal to 3 is 3. And the answer is 3. Answer is the length of longest subsequence. Okay, so this is the problem statement, and here how we can find out. If you try to analyze that the number that is becoming the longest subsequence value is coming from all of these ranges. Let's say here I picked 4. So 4 is coming from this, coming from this, coming from this. So this range is including that element. Or I can say that at value 4, all of these ranges are becoming overlapped. So what I can do to figure out the answer, from all of these ranges, whatever is the value, let's say I pick a value A, and at value A, maximum number of ranges are becoming overlapped. So A can be my answer, because I can convert it to A, and I'm not concerned about the order, because these are 4, 4, 4. Subsequence is picking elements from an array in order. If all the values of subsequence are equal, if I do one thing, if after some cases, if I do some operation and 4 is coming here, it is becoming 4, 4, 4 and 1. I'm not bothered about the ordering, because all the elements are same. I just want to know if that is my candidate to the answer, that how many times that candidate can appear in the array. Now let's try to understand the extreme ends of any range. Let's say I am converting numzi to this range. Let's say this value is A. And what can be this value? This value is, if I add 2k, so kk got cancelled and it will become equal to plus 2k. So if this is A, and this would be A plus 2k. Okay, I hope you understood it. So if the minimum value of any element from any element range is A, then maximum value can be A plus 2k. It means, what I'm trying to say is that if you are having this value, you can definitely convert this value to this value. Let's say A is 2. Now what this range is saying? This range is stating that if my elements are in this value, let's say if I'm having 2 and having 6, or having some other elements, let's say 4, 5, 3, something, any other value between these two values. So if I'm having numzi equal to this, so we are able to convert all of these value to a same value, because 2 was there, 6 was there. I am able to convert 2 to 4 and 6 to equal to 4. How I can do that? My range was from A to A plus 2k. If I subtract k out of it, add k out of it, 2 plus 2, 4. 6 minus 2, 4. And what about others? 5. 5 can also be converted to this 4. 3 can also be converted to this 4. It means that if numzi value is going from 2 to 4, I can convert all the elements which are lying between these two values to a fixed value. My array was given something like this: 4, 6, 1, 2. If it was something like this: 1, 2, 4, 6. Now here, are you able to get the idea that 2, 4, 6, if value of k is equal to 2, then my program is saying, my expression, this expression that I have evaluated is saying that this range can be converted to 4. Okay, because 2 can be converted 2, if I keep 2 as a lower bound of my range and 6 as an upper bound, A plus 2k, then I can convert any value between 2 to 6 to a specific value, which is 4. Okay, so this was the idea behind the approach. Now as I want the subsequence, and that subsequence is having all the elements equal to same number of element, so I am not concerned about the ordering, right? So if we do the sorting of the given array, then we are able to find elements in a specific order. Here I did the sorting of this array. It became 1, 2, 4, 6. Now the approach is, if I am having any element A, the maximum element, if a plus 2k I'm able to convert any element from this range to a specific value. Okay, let me show you by example. Let's say value of a is 1. A value is 1. Then a plus 2k is, k value is 2, a value is 1. The expression will become 2 into 2 plus 1, which is 5. It means all the values between 1 to 5, I will be able to convert it to a specific value. Okay, I can convert the range from 1 to 5 to a specific value. It means I can make all the elements equal. If all the elements are equal, that can be my subsequence of same characters, and that can be the length. So here in this case, I can convert 1 to some value, 2 to some value, 4 to some value. And what should be that value? A plus k. And that is 3. I can convert 1 to 3, 2 to 3, and 4 to 3. So answer is length of this subsequence, which is 3. This is what I was trying to say. Now let's come to the second element. If I consider 2 as a, I can make it from the range a to a plus 2k. A value is 2, then a plus 2k is 6. It means I can make all the elements from range 2 to 6 equal. So from 2 to 6, 6 is coming here. I can make all of these elements equal to a plus k. And a plus k is 4. I can make all the elements equal to 4. The answer would be 3 in this case. Okay, so this was the approach. Now what we did is, first of all, we did the sorting of our given array. And if I sorted on and I got the given array is 1, 2, 4, 6, then what I did is I considered every element starting from index 0 to n minus 1 as a. And then if I know the a, I also know the range a plus 2k. And I will see how many elements are falling in this range, because if those elements are falling in this range, I am able to convert those elements equal to some specific value. So if a is 1, I can convert these 3 elements same. If a is 2, I can convert these 3 elements same. If a is 4, I can convert these 2 elements same. If a is 6, I can convert this element. Yeah, only one element. So this is the intuition behind our approach. And yeah, that's all we have to do. We need to know what is the range. As all the elements are sorted, I have a and I can find a plus 2k. If let's say I'm not able to find a plus 2k because when a was 2, when a was 1, a plus 2k was 5. What I have to find is any element which is maximum and less than this a plus 2k. Maximum element which is less than equal to 5. So maximum element which is less than equal to 5 is 4. So 1, 2, 4. This is the range. The whole range I can make it to equal to any specific element. Okay. So if I give you value a, can you find a value from this array which is less than equal to this 5 or this upper bound a plus 2k? So here the algorithm is binary search, because the array is sorted and I have to find the element which is the biggest and less than equal to a plus 2k. If we call it, let's say b, so upper bound of b, upper bound we have to find. So if we have 1, we have to find any value which is less than equal to 5. If we are getting 5, that means it is good. If we are getting 4, then capture it and move further. So we have to use our same vanilla binary search here. Let me make a revision on that binary search as well. This is I, this is j. Now the problem statement has reduced to this, that for every element you have to find the value which is less than equal to a plus 2k, and a is current element. For 1, I need to find the value which is less than equal to 5. So let's say my mid is at this value. If mid value is greater than that value, in that case definitely we have to move on the left side. Now let's say the mid is coming to this position. Mid is less than equal to this upper bound, or you can say B. If that is the case, what I will do is, this candidate can be the possible candidate, and I will capture it and I will move further. Because let's say this is the case, this is my left, this is my right, and this is my mid. I want to find a value which is less than equal to 5, and this is a valid value. I will just capture it and move further. If that value is crossing the limit, I will just move on the left side. This is just a binary search logic. You will get more understanding when we will write the code for this. And yeah, this much we have to do. First of all, we did the sorting, and secondly, we applied the binary search. And sorting is going to take order of n log n time, and the binary search is going to take log n time. So what is the time complexity overall? Time complexity is n log n. And what is the space complexity? We are not utilizing any extra space, but yeah, the sorting operation sometimes internally requires some space. And let's say in Java it is log n if we are using internal operations. Otherwise we are not taking an extra space. It's a log of n log n time solution. Okay, let's implement this. Here the first thing is that we have to sort the given array, and the second thing is that for every ith element I need to check how many elements are there in the range which can be converted to the same value. So for that I will use binary search logic. Arrays.sort nums, it is sorted, and now I will go for every element I equal to 0, I less than n, I plus plus. Here what is n? Nums.length. And along with that I need to capture some kind of maximum value. One value should always be there, and in the end I can return that max value. And what is this max value? Let's say the first element in my example was 4. This is sorted in after one operation it is sorted, so it has become 1, 2, 4 and 6. For 1, what is that value? For 1 I need to find the upper bound of nums I, which is 1 plus 2 into k. So let's say I find that upper bound is equal to, find is for my function which is implement the binary search logic. Find given array nums, and you have to find the upper bound of nums I plus 2 into k. Find the index of an element which is less than equal to this value. You have current index is 0. If you find the index of element which is less than equal to 5, that is 1. If you have this index and this index, you can find the range of these three values. And what is the range of these three values? That range will be the candidate to my answer. So max is equal to math.max. Range is upper bound minus I plus 1. This range I have captured, and in the end I can return this range. Now we just have to implement the find logic. Private integer find. It is taking nums array and it is taking value. First of all, my left and right. Left is 0, right is nums.length minus 1. Let's say result is storing my answer. It is minus 1 initially, and in the end I'm going to return my result. Now binary search logic, while left is less than equal to right, I will calculate mid. Mid equal to left plus right minus left divided by 2. This is my mid, and now there is two possibility. If nums of mid is less than equal to value, and what is the other possibility? If the nums of mid is greater than value. If nums of mid is greater than value, it means I need to find on the left side. In that case, directly say that right is equal to mid minus 1. If the nums of mid is less than equal to value, it can be equal to value. It means that this can be a possible candidate. I need to capture it and then keep exploring further. To capture, what I can do is result is equal to mid and my left is equal to mid plus 1. The case where I have something like this 1 2 5 5 5 5 and then 7, and now when I am at this 5 is a valid one, capture it and move right. This find function is taking integer array. Okay, so this was the logic, sorting and then finding the length, and length by applying the binary search. Let me test over sample test cases. On the sample test case it is working fine, submitting the problem. It is submitted successfully. I hope you have understood the approach. Thank you guys, bye bye. If you have any doubt you can comment down below.